Okay, so taking a look at this example now, guys. A ball is struck and given a horizontal speed of 15.6 meters per second from a point H, okay, in meters above the ground. The ball hits the ground after 1.2 seconds. What is the horizontal distance traveled by the ball before it reaches the ground? Okay, so that's like an example that we did before. And we are also to find the value of h, which is the height. So if you are to look at this, maybe in a diagram, we are going to be seeing something of this nature. Let's manage this. So the ball somewhere here and then drops on the ground here. So we'll be looking at this as the height, and then this is the distance, horizontal distance that we're looking for, which we can call d. Okay. Then we also see that the this is ux, that's the initial velocity horizontally, and that is there given as 15.6, okay, meter per second. So we have that. I can just write it this way as well, meter per second. So for us to find the horizontal distance, we still make use of our Sx, which is the d that you have there. Sx can then be equal to u, okay, ut plus half at squared, just like we know. Now, this is horizontally. So because it's horizontally, acceleration in the horizontal direction, as you know already, is definitely 0. So this half at squared becomes 0. So you are only left with, so if this is 0, the acceleration here is 0. So I'm only going to be left with ut. And don't forget that u is the u in the horizontal direction, which is ux, okay? So I'm going to be expecting this to be 15.6 multiplied by the time, which is given in the question as 1.2 seconds. So when you multiply that together, 15.6 times 1.2, you are going to get your answer to be 18.72. Let's see if it's going to accept 18.72 fully. 18.72. Okay, just one decimal place, so 18.7. If you mark that, you see that that is correct. Let's move on to the next one. You want to find the height. To find that height, that is vertical direction. So definitely, we're still going to be using, let me use a different color there. Okay, we're still going to be using S, all right, SY, okay, which is our H there now, to be equal to UT plus half at squared as well. Okay. Half at squared. So at this point, what do you have? For the vertical direction H, we know that the initial velocity vertically right here is going to be 0 because it was only a horizontal velocity that we had. So that will make us to have this to be equal to, this is going to be equal to, so the whole of this becomes 0 right here. So I'm only looking at half, okay, multiplied by the acceleration, which definitely we know already as 9.8, okay, and then multiplying that by t squared, that's 1.2 squared. So if you quickly do that calculation, just for that part, you're going to be having 1.2 squared times 9.8, okay, and you're going to be dividing that by 2, half of it, and that should lead us to 7.05, which is approximately 7.1. So let's see, 7.1 approximately. We'll mark that. That is correct. So guys, let's move on to the next question. Next example very quickly, based on what we've learned so far, okay? So the next one right here is saying that an arrow is shot horizontally from the top of a castle tower. It strikes the ground 60.3 meters from the tower, 2.1 seconds later. Guys, what can you see here? For me, I can see that we were given distance, and we were also given time. Now they want us to find the initial speed of the arrow, and they want us to find the height of the tower. Okay, this is a case of change of subject, I believe. So if I'm to do that, I'm going to be having, it's an horizontal projectile. So this would be Sx to be equal to ut. Okay, so I'm not going to be writing all the formulas anymore. So this is just ut, because this is going to be your ux. Don't forget, this is ux. You see that I'm not writing half at squared, because I know in the horizontal direction, acceleration is always 0. So no more half at squared there. So I'm just simply doing this. So that simply means that what I have here is simply Sx, which is given as 60.3 in the question, 60.3, and that is going to be equal to ut. What's my time? That's 2.1, so I can just multiply and have 2.1 u. Don't forget that u is actually ux. So ux in this case, definitely, is supposed to be equal to 60.3 divided by 2.1. So just like I said, it's just a case of change of subject. So if you divide that by 2.1, you should arrive your answer at 60.3 divided by 2.1. And that gives 28.7. Okay, 28.7. All right. So let me just 28.7 to 1 decimal place. Okay, or 7 1 to 2 decimal place actually. So let me put that in 28.7. Let me see if it will accept 0.71. Okay, no, that's 1 decimal place. That's correct. Now to find the height is the vertical motion. So that will be SY. Excuse me. So if I'm looking for SY in this case for the height, SY is going to be equal to, okay, is going to be equal to ut plus half at squared. But in the vertical direction, we know that we have acceleration due to gravity. And then you can also know that it is shot horizontally from the top of the castle. So there is no velocity going upward. So that simply means that initial velocity for y is 0. So the first part is gone. I'm only left with my half at squared. Okay, half at squared. So since I'm left with that, all right, solving that, I'm solving half. The acceleration is 9.8, as we already know, times 9.8 right there. Okay, and then we multiply this also by the time squared, which is 2.1 in this case, 2.1 squared in this case. So when you solve that, you get your answer. You can simply quickly multiply 2.1 squared, okay, and then multiply it by 9.8, all right, and then after that you divide it by 2, half of that, so that you land yourself on 21.6 meters. So quickly put that in 21.6 meters, and we have that correct. Well done, guys. So this is how this goes. You can see how the calculation has gone. It's quite easy. The points you have to remember is very, very important, and those points are easy to remember. Please take note of that. Acceleration in the horizontal direction is always 0. And then velocity in the vertical direction is also 0 if the projectile is projected only horizontally, okay, not through an angle. So our next few examples that will be coming up now, we'll be dealing with projectiles that is projected through an angle, where we will need to resolve the velocity vertically and also horizontally. So in my next video, I'll be showing you calculations on how to do that, and I'm sure you're going to enjoy the class, just as you have enjoyed this one. Okay, guys, thank you very much for listening. I'm going to see you in the next class. Thank you so much, everyone. I remain Mr. Ayodeji, also known as David Math. See you in the next class, guys. Bye for now.